Hi students, this is Dr. J. Jayodaya, Associate Professor in AAA Department, RMD Engineering College. So in this video, we are going to discuss a simple problem. So now you see, a conducting loop of radius 10 centimeter lies in the Z is equal to 0 plane. The associated B vector is equal to 10 into sine of 120 pi into t into Az vector milliweber per meter square. Calculate the voltage induced in the loop. So this is the problem. So first see how to write what are the data given in the problem. Now you see here they given the radius. So radius is represented by the symbol R. So R is equal to 10 centimeter. So first I'm converting the centimeter into meter. So that's why 10 into 10 to the power of minus 2 meter. Okay. Then next here they given the condition. So the conducting loop of radius 10 centimeter lies in the Z is equal to 0 plane. Appa Z is equal to 0 plane, there is no height in the Z axis. That's why it implies XY plane. Okay. The next they given the B vector value. So B vector is equal to 10 into sine of 120 pi into t into Az vector. Okay. Then next, first we have to find out the pi value. So you must know the induced EMF. According to Faraday's law, we can write the magnitude of the induced EMF is directly proportional to rate of change of flux linkages. According to Faraday's law, we can write E is equal to minus d pi by dt. If you want to find out the induced EMF or the voltage induced means, you must know the value of flux. Then only it is easy to find out the induced EMF. Okay. So for that reason only, we are calculating the flux value. We know the formula flux is equal to integration B vector dot ds. So in this problem, they given the B vector value. So next we have to find out the ds vector. How to find out the ds vector? Na? Already you know that Z is equal to 0 plane. That means XY plane. So XY plane perpendicular is Z axis. So therefore we can write ds is equal to R into dr into d pi into Az vector. Okay. So now I know the value of B vector and D vector. Okay. Just I am substituting the value in this place. So this is a B vector value. This is ds vector value. Then next we know that Az vector dot Az vector is equal to 1. Okay. The next in the cylindrical coordinate system, the pi limits varies from 0 to 2 pi. So that's why here I'm indicated the pi is equal to 0 to 2 pi. The next important thing is here they given the radius value is 10 centimeter. We are converted that centimeter into meter. So we are getting the value is 0.1 meter. So therefore, the minimum value is 0 and the maximum value is 0.1 meter. Okay. The next you know that this 10 into sine of 120 pi into t, this is a constant value. So we can take this out. Okay. So what are the remaining terms? D pi, then r into dr. Already I told you this Az vector into Az vector is 1. Okay. So therefore, here you see integration 0 to 2 pi d pi. You know that integration of d pi is pi. Okay. Then next, I am coming to this second integral. The limit varies from 0 to 0.1 r into dr. So what is the integration? General format I think you know very well. So integration of x power n is equal to x power n plus 1 divided by n plus 1. This already you know that. According to that, we are going to write the value here r power 1. So therefore, integration of r power 1 is equal to r power 1 plus 1 divided by 1 plus 1. So that's why we are getting r square divided by 2. Here the limit value is 0 to 0.1. Okay. Then next you have to substitute the limit. So you know that how to substitute the limit. Okay. So first you have to substitute upper limit minus lower limit. So here the upper limit value is 2 pi. So 2 pi minus 0 is equal to 2 pi. Similarly, r square. So here you have to substitute a 0.1 square divided by 2 minus 0 square divided by 2. So you will not get any answer for that. 0 square divided by 2, 0 only. Okay. Then after that, you have to simplify this value. Once if you're simplifying, then you will get flux. That is a pi is equal to 0.314 into 10 to the power of minus 3 into sine of 120 pi into t. So per unit of flux is Weber, that is WB. Now I know the value of flux. The next I'm moving to the voltage induced or induced EMF is equal to E is equal to minus d pi by dt. Already we are completed the pi value. So therefore minus d by dt of, next you substitute the value of pi in this place. Okay. Then after that you see this 0.314 into 10 to the power of minus 3 is constant. So therefore we can take that value is out. So therefore minus 0.314 into 10 to the power of minus 3 d by dt of sine of 120 pi into t. So you know that the differentiation of sine omega t is equal to omega into cos omega t. Okay. So here omega value is 120 into pi. You see. So from this we can, this is sine omega into t. So here omega value is 120 into pi. So therefore the differentiation of sine omega t becomes omega into cos of omega t. Okay, that's why here you see minus 0.314 into 10 to the power of minus 3 into 120 pi into cos of 120 pi into t. Once if you're simplifying this now, then you will get the induced EMF or the voltage induced is equal to minus 0.1183 into cos of 120 pi into t. So in this way only you have to find out the induced EMF. I think this video is useful for all. Thank you for watching this video.